Hi, I'm Steven and I work for Global Dots, and we are a team of cloud enthusiasts and technology hunters. In the last 12 months we've been working on something that we like to call the new cloud security stack. This includes things like identity and access management, zero trust access, cloud workload protection and open source software security. And it's this last one, open source software security, that I want to talk to you about today. Now, I'd like you to imagine a situation where a developer comes to you and says, hey, I want to use the latest version of Nginx in our development. And you think to yourself, okay, it's the latest version, it's Nginx, it's one of the most popular used containers on the internet, should be fine, go for it. Well, you've just made a big mistake, because the latest version of Nginx has 80 vulnerabilities baked in as of last year. So if we replay that conversation and a developer was to come to you and say, hi, I've found a container on the internet, it's publicly available, it only has 80 vulnerabilities in, can we use it? You're not going to say yes. So we have a disconnect between what we think is safe and what is actually safe. And open source software is not safe even at the latest version. So how has this come about? Well, open source software is the building blocks of development now. So you don't want to go and code something yourself, it's already been done. And typically from the lowest level, somebody's coded a very basic function, and then somebody else has baked that function inside their code, and you're building something up here and you bake this code in here, and you have this big long list of dependencies, and you don't even know what's in your code anymore. So if something happens 3 levels deep and a vulnerability happens somewhere way down here, it gets introduced into your code all the way up here, and you didn't know about it. But I guarantee there's one person who knows about it, and that's the hacker who's scanning for new vulnerabilities all the time. So you could have a vulnerability released into your production environment through a piece of code you didn't even know was there. And how do you stop this? Well, using a tool like Snyk, you can scan your developer environment, your IDE, so that as you're actually coding in your environment, it will show you vulnerabilities that you're adding in. You can add it as a CI/CD pipeline gate, so as you're compiling your code, it alerts you to vulnerabilities that you're adding in. You can scan repos natively, and you can also scan your live production environment, so you get full visibility of where these vulnerabilities are in your code pipeline. And I think probably the best thing to do is to jump into a demo and show you what the software looks like.
Let me go into the platform now and show you what the actual user interface looks like. Here you can see I'm looking at my web app, and I see a list of pending tasks and number of vulnerabilities that I can see in my projects. In the drop down here, you can see I can switch between all the different projects. This allows you to keep your reports and your vulnerabilities all separated into the different projects within your organization. The first place a customer usually goes to is over to the integrations to integrate that with their DevOps pipeline. So source control tools, container registries, container orchestrators, CI/CD pipelines, ID plugins, the list goes on. But what's quite useful to look at is let's scan a project. So I'll go to my Snyk code application, I'll choose add projects, and then up comes a list of my integrations that are already configured. I can click on GitHub and see a list of the projects that I can get back. I'll click on one called Goof and one called Java Goof. Java Goof is using Java, and Goof is using Node.js. I'll then run a scan on those. And what we do at that stage is we go and look at that repository and we find the interesting files. So we look for any Docker files for the container. We look for any manifest files for the open source code. We look for deployment YAMLs and Helm charts for the infrastructure as code. And then we look at the source code that the developer writes for that SAST scan. And when it comes back, it looks a little like this. You can see we've got a report around each of those layers. The code analysis, package JSON, Docker file, and deployment.yaml. As a developer, the first thing you'd be interested in is, oh, there's some vulnerabilities in the code I have written. Let me open that up and have a look at the report and show you what they look like. Here you get a list of the vulnerabilities or weaknesses that we've found, organized into high, medium, and low. Here we can see the type of weakness, so cross-site scripting, command injection, SQL injection, and so forth. If I want to fix one of these vulnerabilities, I would open up the details pane, and here we would load the full stack trace or trace from source to sink of that vulnerability, known as taint flow analysis. And on the right hand side, I can actually traverse that through the code that I've written or somebody else in my team has written. When I go to the fix analysis page, we get some detailed information about this type of weakness, the types of attacks, and how to prevent it. But we also get some links to good open source projects that have solved this problem previously. So I can link through those, decide I want to look at one of those commits that fix the problem, go over to GitHub, and that gives me an idea of how to fix that problem in my own code. At Snyk, we're not just about telling you where the vulnerabilities are, but it's all about how do we fix them and how do we fix them in a prioritized way. Okay, so let's imagine now we've gone down that list and fixed all of the vulnerabilities in our developer code. The next stage is then, okay, let's look at the open source code. And I can open up this report and you can see what this gives us. Again, it gives us a prioritized list of the vulnerabilities, but here we have further prioritization. Here we're looking at whether a fix is available, what type of exploit it is it mature, proof of concept, known exploit, or no data. So the developer coming to this report can easily see that this is the next best action. And they can click fix this vulnerability, and then we'll first go to an interim screen where we can refine what this pull request looks like, or we can scroll to the bottom and then open that pull request in GitHub. And that pull request actually has a nice commit message. It lets anyone know what's being fixed, and then we can go and see what files have been changed, and here it is. So that means actually most developers using the Snyk platform or leveraging the Snyk platform will not log into the user interface. They'll see it in the tools they use every day. So here, using GitHub, they would have the call to action to come and look at this pull request and potentially merge in that fix. But what we're also doing is scanning the license and security issue delta. So has this pull request added any new license issues or new security issues? In that way, we're stopping new vulnerabilities from going into that repo. So on the one hand, we're removing vulnerabilities, and on the other hand, we're stopping new vulnerabilities going in. So you can see over time, you're going to get that reduction in the number of vulnerabilities. Now, you can also look at this open source code within your IDEs. IDEs are commonly used by developers for actually writing their code, and we integrate with the whole JetBrains suite, as well as Visual Studio Code, Eclipse, and others. So here you can see I've actually run a scan, and I've found vulnerabilities in 3 of those layers. So the open source vulnerabilities and the code, security, and quality. I can click on this here and see, okay, what's some information about one of these vulnerabilities, and then at the bottom, how do I fix it as well? And it gives me the version that I'm supposed to go to fix. I can also see code security issues in each of the files that I've written directly within my IDE. And again, we get the type of vulnerability, we get the pointed to where that vulnerability is, and we get the information from good open source projects about how this has been fixed in the past. It's a similar experience to the user interface, but again, at Snyk, we're meeting the developers where they work. Okay, on to the next layer, which is how do we make sure the containers that our apps get deployed upon are as unvulnerable as possible? Well, we also scan a report on these. And here you can see the first thing we're looking at is the base image for that container. This base image, node 6 stretch, has 904 vulnerabilities. Not good at all. So we produce this table which is updated every day, which lets the developers know possible alternatives they could use. And here you can see there's 2 alternatives with just 58 vulnerabilities. I say just 58 because it's quite hard to remove all vulnerabilities from containers. But here you can see we've reduced our number of vulnerabilities by an order of magnitude and more. Now, what I would do to go and fix the problem in my case is I would click on open that pull request. I could then go and change the base image of my container. But we also give you that full prioritized list of vulnerabilities as well. And this really allows us to decide what to do about these vulnerabilities. For instance, we've got a vulnerability in curl here. Should we update it from deb9u9 to deb9u11? Or can we actually look further into this and decide, actually, I'm not using curl on my live running container. I'm using it during the setup. So can I perhaps remove curl from my container entirely? And this dependency tree will let you see where the vulnerabilities are coming in from and subsequently help you in that process of hardening your containers. Here I can remove curl and I'll know that 3 vulnerabilities have gone straight from my container. Okay, the last final stage that we're looking at in Snyk is that infrastructure as code. And here we're looking at deployment.yaml, which is a Kubernetes configuration file. So when we look at that report, on the right hand side we show you the actual file. On the left hand side we show you the vulnerabilities that we've found. But again, at Snyk we want to show you how to fix things. So if we open one of these up, we get what the issue is, what the impact of the issue is, and how it can be resolved. So I'm given a great clue about how to go and solve this particular vulnerability. Run as non-root. I would add it here or below the eyeball and set that to true. I could then republish my Kubernetes cluster and we would rescan this application and that vulnerability would be gone. Now, all of these vulnerabilities are configurable by the policies within Snyk. So we have policies around security and licenses. So we can tell developers which licenses they should be using and which vulnerabilities are higher or lower priority as well. Overall, there's also a report section which lets you understand the view of all your application or single application or even ecosystem towards the right hand side there. And that's the quick run through from the Snyk platform. Thank you very much.
Well, I hope you learned how a tool like Snyk can help you to see the vulnerabilities that you're introducing into your code, how it can help you to create a more security conscious mindset and help shift those problems left and make sure they don't make it to production.